So let's talk about the Kruskal-Wallis test, and we'll talk about effect size later. We're just going to talk about the Kruskal-Wallis test right now. All right. So remember we did ANOVA, and ANOVA was where we were comparing the means of different groups to see if they were the same. Well, Kruskal-Wallis is when we do the same thing as ANOVA, but we have non-parametric data, which means, think about it. Remember with ANOVA, I was making the assumption my data was normally distributed. It made that really pretty bell-shaped curve and it would pass the normality test. Well, this test is when it doesn't pass that test and the data is non-parametric. It could be all sorts of different distributions. So, like other non-parametric tests, you perform it on ranked data. So you convert the measurement observations to their ranks in the overall set. So the smallest value gets 1, next smallest gets 2, and so on. So you lose the information on your ranks for the original values, which kind of makes this a less powerful test than one-way ANOVA. In the real world, I run both of them just to see. A lot of times I get the same results, so it kind of strengthens my results if I can say I ran both and I got similar results. So, all right, you're really not going to have to worry about this right here, but let's talk into it. All right. So another assumption of a one-way ANOVA is that the variance within the groups is equal. So, or the variation. So while this test doesn't assume the data is normal, it does assume that the different groups have similar distributions and groups with different standard deviations have different distributions. So if your data is heteroscedastic, this test is no better than a one-way ANOVA, and it may be much worse. So instead, you run something called a Welsh ANOVA, but we're not going to worry about that in this course. So for this course, if your data is non-normal, use the Kruskal-Wallis test. I just really want you to see how to use it and how it basically, when you look at data, you need to see, is it normal, non-normal, and then what the distributions are. Okay, so your assumptions are your dependent variables should be measured at the ordinal or continuous level. Your independent variable should consider of 3 or more categorical independent groups. You should have independent observation. That means there's no kind of relationship going on between the groups. And the distribution of the scores of each group of the independent variable have the same shape, which means basically the same variability. Again, we're not going to worry about that much in this class. We're just going to worry about if your distributions are non-normal, we're going to use the Kruskal-Wallis test. Okay, your hypotheses are, the null and the alternative hypotheses are, the null is the medians of the group are the same. The alternative is the medians of the group are not the same. All right. Think about this. You saw this in ANOVA, but instead of the word median, you saw the word mean. Basically, we're running the same test. ANOVA, you use the means. Kruskal-Wallis, you use the medians. All right, and you can also see that HA written a few other ways, but for the course, you can write it like you like as above. Also, Minitab writes it a little bit different. I'm cool if you want to write it based on what Minitab gives you. But remember, you want to make your hypothesis based on the number of groups you're comparing or what the groups are. Like we'll see in example 1, I'm looking at different months. I need to put the medians of the months are not the same, just so I know what you're looking at.